So here, input is what we're putting into our equation. So similar to that computer program thing that we did like a couple of weeks ago, right? So if the input is 0, so 5 times our input. So in this case, 5 times 0 gives us 0, and then we can subtract 2. That leaves us our output of -2. So we do that for each of our inputs. So the input is 1. 5 minus 2 is 3. Our input is 2. 5 times 2 is 10. Minus 2 is 8. The input's 3. 3 times 5 is 15. Minus 2 gives us 13. Finally, 4 times 5 is just 20. Minus 2 is 18. Okay? Yeah. So for each of those inputs, we would get an output, right? Based on this relationship that we have between our input and output. Sort of like a relationship that you might have between, let's say, a toothpick and the number of closed shapes that you can make. It does. Okay? So here we're going to calculate the first difference. Right? I encourage you, as you start getting familiar with this, just to write out the arithmetic. Because especially if we got negatives in there, you're going to get confused. Alright? So it's this number minus that number. And that's where the confusion comes in. Here we got a double negative. Right? So negative minus negative first is positive. First difference is 5. 8 minus 3 is 5. 13 minus 8 is 5. And 18 minus 13 is 5. So from this table of values, what can I interpret? How can I see this relationship between the input and output? What is the relationship? How can I describe the relationship? Katie?
Linear.
It's linear? How come?
Because the delta x is constant and so is delta y.
Whoa. I love that. Linear because our delta x is, so what you say is what?
Constant.
Constant. And delta y is constant.
Wouldn't it be delta n and delta x?
Yes. But we're going to call this x and y as well, right? Yes.
Does your x have to go up by 1? But can it just like go up by 5 constantly?
Yeah. So that's a good point, is that your delta x, or your change in x in our first difference, doesn't have to be 1, right? As long as it's constant, right? I mean, it could have been argued that when we did the toothpick thing, well, the number of toothpicks was our independent variable. And that affects the number of shapes that you have, right? So the number of toothpicks could have been growing by 3 to get your squares, right? So there your x was growing at a constant rate, which is fine. So how can we determine the rate of change here? Now that we discovered this is a linear relationship, how can we determine a rate of change? In other words, how fast is our output changing based on our input? How quickly is it changing? How quickly is the output, or a y, brackets here, how quickly is a y changing based on an x value? What is the rate of change? How can we calculate that? 2 ways. Oh, what's the first way?
Here it's delta y over delta x.
Okay. What is that?
5 over 1.
Well, what is delta y over delta x? What is that definition again?
1 over 1.
No.
rise over run. Actually, it should be like this. Delta y over delta x. So this is really rise over run. And a couple said this is really our slope, right? We should use the variable m. So here's slope. And this is known by the variable m. Okay, so here, what's our delta y? What's the change in y? 5 over delta x. What's your change in x? 1.
Slope is 5.
So it's just 5. Does anybody remember what this special value is called? What's that value called?
Wait, where did you write?
I just put a square on -2.
Oh.
Okay, what is that value called? Can you remember from like, I know, like 4 almost a week ago? It's
The y.
y-intercept.
Yeah, it is.
So that is our y-intercept. Why is that called a y-intercept? How come it's called a y-intercept? Jenny?
Because that's when it crosses the line. Like, yeah. It's when the y is 0, no, the x is 0.
Okay, so we draw our Cartesian plane. Right, so there's our x-axis and there's a y-axis. Right? So if I start doing a scale on here, 1, 2, 3, -1, -2, -3. I have a point right here, what's my x value? I have a point, let's say right here. What's my x value? What's the x value of that point? 1, right? What's the x value of the point of a point here? 2. What happens if it is right here? What happens if it's right here? Right? So here, we'll see what Jenny's saying is along the y-axis, that's where x is equal to 0. Right? So in our equation, when an input is 0, our value, output, is -2. So we will get a point 0, -2. This is where that line will cross the y-axis. That's why it's called a y-intercept. Yes, Andrew?
Would it work if, say, there was -2 input and 0 output?
-2 input?
Like, is there a 0, like, could y be 0 or no?
Can y be 0? Well, what happens when y is 0 and the input 0? Where is it crossing?
Right,
Right in the origin. But is that going to happen for this particular relationship? Like when x is 0,
I'm just asking.
well, when x is 0, what is our output?
If x is 0.
Yeah. Yeah, so not in this relationship. It doesn't go through the origin. In fact, we learned way back in the first unit, the first lesson, if our line goes through the origin, what kind of relationship is that? Direct, right? It's a direct relationship or direct, can't remember the term right now. Direct variation, thank you. Right, so then if it goes through the origin, that's direct variation. Okay. Question, Pooja?
I get all of that, but I don't really get output equals 5 and input equals -2. Like, how did you start your graph with just that information?
Output is 5?
Yeah.
Where?
No,
okay.
she doesn't understand the way you plotted the equation. So it's actually output is equal
Right
to
here?
5 times input minus 2.
You mean right here?
No, up there.
This table? So
Right.
you don't know how you
Underneath the date. Right there.
Oh, that's the relationship I just said.
Okay.
That's just our relationship,
Oh, it's your, like,
right? It's just an equation that I came up with. Alright, so I'm gonna just take my input, multiply by 5 and subtract 2. Okay?
Yeah.
Yes, Vince?
I just have a question, like, if the first differences are all the same, would that mean the equation is linear too?
Yes.
Yeah, so the first differences here are all the same, it's linear. But and this is also the slope, or rate of change, only if the delta x's is 1. Okay? So that's where we see a connection between the first difference and the slope. Right? In this case, because the change in x was just 1, our first difference also is the same as our slope.
So then if it was 2, it wouldn't be.
Sorry, what was it? If this,
Yeah, that was it.
if it changed by 2's,
Yeah.
then we have to take this and divide it by 2, because this is where we get this equation from delta y over delta x. Because here our delta x would be, if it's differing by 2, it would be 2. Okay? So we can define this line, or this equation, as y is equal to this relationship with x. What value might we want to put in here? What is the rate that we're changing x by to get y?
Oh,
Would you?
so y equals 5x minus 2.
Yeah. So this is our rate of change, or this is our slope. And what we're discovering here is that to complete the relationship, we put in a y-intercept, right? When x is 0, right, then our y value is -2. So we get that from this equation. We give this a special letter. This is called y.
And y equals to mx plus b.
So in general, an equation of a line is y is equal to mx plus b. Okay, so that defines the relationship between x and y that's linear. We have the slope, the rate of change, multiplied by x, and then we offset it, or we get an initial value of this y-intercept. Any questions on this? Who did not get a chance to print out the handout that I posted on Blackboard? Or actually, it might be easier, who did print it out?
I downloaded it. I put it on.
So you got a copy?
I already did. So I
You printed it? Oh, you guys got one? Good. Got it?
I'm done. I give up.
So, essentially, we're given a line or an equation of form y equals mx plus b is said to be in slope-intercept form, because when it's in that form, we know two things about this equation, about the line. What the slope is, and what the y-intercept is. So here the slope is, how do we fill in that blank? M. So whatever m is in our equation, and what's the y-intercept? E. Just B. Okay, so here in the first equation, example 1a, y is equal to -1/2 x plus 3. So we're asked to state the slope and y-intercept and then graph it. Well, what's the slope?
1/2, -1/2.
-1/2. Okay? And what's the y-intercept?
3.
Okay. So we have equation this linear equation in this form. It's the most awesome form ever. Because we can see two important things from it. I know, it's almost an oxymoron,
I like that.
like a good teacher. So how can I plot this? How can I graph this line now?
Put 1 point on
Well,
0, 3.
let me do our scale first. 1, 2, 3. There's my x-axis. There's my y-axis. 1, 2, 3. -1, -2, -3, -1, -2, -3. So I expect you guys to do this as well when you do your grids. You're graphing lines. If you don't, you're gonna lose technical marks.
It's going to be 1, 2, 3.
Well, however,
To the
whatever
scale.
your scale is. So how would I begin to start plotting this? I think Megan was saying something. Was it you?
Yeah. Put a dot on 0 and 3.
On 0 and 3. What do you mean by 0 and 3? So it's, what do you mean by 0 and 3?
X. 0.
So 0 comma 3, so it's 0 for
Yeah,
x.
0,
Okay. So we'll label it 0 comma 3. Why put a point there? Why are we putting a point there?
That's a line
That's
to
the
set.
y-intercept.
Yeah, so that's where the y-intercept is. That means that point, our line will cross through that point, or that point will be on our line. That point will make our equation true. Why won't we just start with the slope? It's the first part of the equation. Yeah, we need a starting point. Slope doesn't give us a starting point, right? It gives us sort of relationship between the points, but we need a starting point. So now that we have a starting point, can we get to the next point on here? We say yeah. How come? What do we do, Pooja?
Since it's -1/2, the rise would be
Good.
-1.
So here we got, so here I'm going to say rise is -1.
Yeah, and then the run is -2.
Is -2?
Oh, it's 2.
It's just, so take our negative sign, put it with one or the other, but do not put it on both. Okay? So you're going to leave it with the rise then? You're going to leave the negative with the rise? So the run is just 2.
So it means it's
So from this point, we're going to go, so rise is -1.
So what?
Down.
Well, rise is what? Up or down?
Down.
Down.
Well, it's up or down, so it's up and down. And we're going down 1 because it's negative. And then run is 2, so it's over here. We're going to measure, I'll do it again. 1 down, 2 across. 1 down, 2 across. Right? So I'm just going to put several points on here so that I can kind of see what my straight line will be. So you need arrowheads. And you need to do this with a ruler or a straight edge. Yes, thank you.
You can be
C is written.
Now here's something that's interesting. What's this point over here? What's the coordinates of that point? 4, 1. So that means here, right down here, x is equal to 4. Y is equal to 1. Well, what happens when I plug 4 into our equation? Y is equal to -1/2. So I plug 4 into our equation. Plus 3. What do we get? Who wants to work it out for me?
Oh.
Vince?
Yeah, we get 5.
What negative? 1/2.
Sorry.
times 4.
1.
What was that give? Negative 1 half times 4 gives us
Maybe.
negative 2 plus 3. So y is equal to 1, which happens to be a y coordinate.
Look at that!
That's what these points or these coordinates mean, is that our x and y values will match up to make this equation true. So no matter what points I choose on our line, it'll fit nicely into our equation and match it. It'll make the equation true. That's what a linear relationship means. Okay? We take our x and y and it'll work out. Y is equal to negative 4. That's a weird one. I don't see an x. Where do I start with that?
And then slope is 0.
Plotted this already.
Katie?
The slope is 0 and the y-intercept is negative 4.
Yeah, so this is still our b value, right? So we can still plot it as negative 4 over here. But I think Megan and Katie both said our slope is 0. There's no x there because the coefficient of the x really is 0.
So then it's 4.
So it's just horizontal. In other words, no matter what the value of x is, what's the value of y? No matter what the value of x is, what's the value of y here? In this equation?
0.
No.
It's 1, 2.
No matter what the value of, look at our red line, no matter what the value of x is, what's the value of y? Negative 4. That's why we have the equation y is equal to negative 4. No matter what x is, it's negative 4. No matter how hard you work on your test, they can give you negative 4. Suppose that. This has to be math teachers. X equals 5. I'm going to do that.
Oh, this is
Same thing? Yeah, it's just a little bit different. Right? Now we're saying that no matter what the y value is,
So it's this way.
thank you, what's this way?
Vertical.
Vertical. Let's do black for that. No, let's do green. So where's x equal 5 here? Right here? So that's where we're.
X equals 5.
That's where x equals 5. Here's x equals 5. Right? So for x equals 5, we just get a vertical line. That means no matter what the value of y is, no matter what we put as an input for 5, x, it just stays the same. We don't get any change in, the output is always different.
Can our test be out of 5 if it's like that?
Can you test out of 5?
but then it's always going to give you negative 4.
Let me munch on that for a while. Okay, D, we want to do a similar process. All right, I know I'm hungry because it's close to lunchtime. Sarah? Okay, let her ask. What's the question?
I was just gonna ask for B, how do you know that it's like not sloped, like negative 4 is slope?
Because there's no x value tied to it. Remember in our equation, slope is the coefficient of the x. If there's no x, then it's just her v value. Okay? Whoa. So, I don't have time to finish this. I want to go for lunch. I would like to work through the examples, but do it as homework. Try them. I'll take up any questions that you may have in class or next class. Alright? So finish the page. So it's basically what I've got on Blackboard. Finish the page, and then you have some questions at the end.